wide array of services and amenities. Friendship Village is managed by Life Care Services, which started in 1971 and currently manages 133 communities in 32 states. Life Care Services manages 33,600 beds and employs more than 23,400 staff. Friendship Village is designed to offer an environment that enriches your life. The village's objective is to offer a lifestyle with services and programs based on your interests that will complement or augment your current lifestyle and well-being. The village's design allows for creativity and healthy lifestyle activities in a comfortable environment. As a life care community, the village offers residents a wide array of amenities and services, including the availability of on-site assisted living, memory care, healthcare center, a nurse practitioner clinic, and long-term care if needed. To learn more about Friendship Village, please visit us at friendshipvillageaz.com or call 480-831-5000. Friendship Village is proud to be a sponsor of the Tempe Historical Society and look forward to today's lunch talk. Thank you.
Oh, we're off to a good start this morning, aren't we? Our thanks to Mark Young of Friendship Village, and let me say good morning to everyone that's watching today, to the fifth in our series of Tempe Historical Society lunch talks. We're all adjusting to this new format, but looking forward to maybe next season when we'll actually be able to have everybody attend these lunch talks live. Everybody misses the pastries provided by Marianne Quillis and coffee and just the camaraderie of everyone getting together. But we're doing the best, and we are actually increasing our audience size as a result of having these presentations done virtually. Today's a really a special event, and for a couple of reasons. One, this was scheduled for last March, and that's when, or last April, and that's when the coronavirus pandemic hit, and we were not able to quickly adjust to virtual presentations. So this was canceled or postponed, but actually we think the timing is better to have ASU now because of what is going on Mars, and with the landing of the Perseverance. You'll hear more about that as we move along. But our presentation today is from the School of Earth and Space Exploration. And this is something that is important to everyone. I know in troubled times, people say, why are we spending all this money to explore another planet or try to go to the moon when there's so many needs back on Earth? But if you look at it realistically, much or most of what we have today, the development of computers and technology, is a direct byproduct of the space program. And ASU has been directly involved in it from the very beginning. Also, just on a personal note, this is a special presentation for me because way back when, I had always desired to be a theoretical astrophysicist. That's the highest level, the Stephen Hawking, Einstein kind of thinking. And reality set in, and I found out that my math skills were not that great. I was pretty good at basic astronomy and things of that sort. But I like to think that today I can consider myself a theoretical astrophysicist. So I think I fit well into the conversation that we're going to have. I just want to introduce to you those who will be participating in today's program. Rick Ayling is the manager of the Community Outreach Program at the School of Earth and Space Sciences. We have alumni Alicia Hyatt and Zena Moody, who is a NASA space grant intern and she is in her third year of microbiology major with a research focus in the Center for Meteorite Studies. And I'm sure we'll get some sort of explanation in common language what that is all about. And we've had a lot of help putting this rather complex presentation today. I want to say thanks to Meg Hufford. She's the senior coordinator at the ASU School of Earth and Science Exploration. And Kim Batista, who's the special events coordinator in that program. Kim has been particularly helpful with the technology side. So before we start, you probably guessed that you're seeing it on Facebook Live. We are doing our part through Zoom, and that's what makes this whole thing a little bit complex. We invite questions. It won't be so easy as in a Zoom format where there's a chat, but you can leave questions in the comment section in the Facebook Live format. And if you have any questions, we will aggregate them and ask them to our presenters at the end of the program. Also, everything will be enhanced because there are special videos and slides. If you can go to your full screen on Facebook, that'll give you a much better view of what our speakers are talking about. And then finally, for the Friendship Village community, which is watching on closed circuit television, if you have any questions, please forward those to Carter Rogers, who will then pass them on to all of us. So with that, it is a pleasure to recognize today's presentation from the School of Earth and Space Exploration. We're going to learn quite a bit about this school, highlighting several past and current missions with NASA, some geological discoveries, engineering advances, and what to expect in the future missions and upcoming events at the School of Earth and Space Exploration. Hopefully in the beginning too, we'll learn how long ASU has participated in national and world science experiments and expeditions. ASU has a really long history, and that's why we're also celebrating it as part of Tempe's sesquicentennial. So please welcome Rick Ayling and Alicia and Zineb, and I turn it over to them.
Hey, Meg, you might want to restart. We don't have volume on that the movie.
Meg, you might have to stop sharing and reshare.
For humanity as
Oh, there we go. When your mic's on, we can hear it.
Got it. Sorry. Here at the School of Earth and Space Exploration at Arizona State University, we are deeply committed to high-impact scientific discovery. We ask important questions with deep consequences for humanity as we explore the great unknowns of the Earth, our solar system, and the universe. Our students work with faculty in astronomy, cosmology, geosciences, planetary sciences, exploration systems engineering, and science education. We are breaking down the boundaries between these disciplines to answer the biggest questions that cannot be answered within a single discipline. Our degrees are designed to challenge students, to encourage critical thinking and scientific inquiry, and to inspire exploration. At the school, we're exploring all of Earth's continents and looking at the future in terms of climate and water supplies. We study astrobiology and seek to understand the relationship between life and a planet. We're at the very center of the community trying to understand whether Mars is habitable, maybe even in the present day. We have one of the largest collections of meteorites in the world, the largest at any university. And we have some of the best university facilities for building flight instruments and spacecraft for exploring our moon, planets, asteroids, and the unknowns of the universe. Here at the School of Earth and Space Exploration, we are combining the strengths of science, engineering, and education to set the stage for a new era of exploration of our Earth, our universe, and of the future.
All right. Well, thank you, Vic, very, very much for the invitation, and thanks for the introduction. Both of those are special, and I
welcome
would like
everyone
to.
to this colloquium.
Sorry. Oh, so I just wanted to kind of just give you a little overview of myself and our place, a little update on what ASU is doing right now, and what it's going to be like to come back and visit us once we open up again. So as I was introduced, I am part of a community outreach group. And so at the School of Earth and Space Exploration, we kind of see ourselves as being a three-legged stool. One of them is that we are a teaching institution. So yes, we have students, and you're going to meet some of them today. And we confer degrees, and we have professors, and we have classes, and all of that stuff goes on. We are also what we call a Tier 1 research institution. And what that means is that the School of Earth and Space Exploration, along with other facilities on the ASU campus, we have access to the biggest and best and most amazing research grants that are offered by things like NASA or the National Science Foundation, or medical grants, or all kinds of different things are available to us because of the expertises we bring to the table. The third leg of our stool is something that's important to me and my colleagues that have joined us here today, but it is actually no less important to ASU, is we also take very seriously our role in the community. We don't believe that we can be an institution just kind of plop down right into the middle of Tempe and not have some sort of responsibility and some sort of activities that go on between us and the citizens of the community. It absolutely drives me crazy when I hear people call and say, do you have to be a student to come see a program at ASU? The answer is no, of course not. We are open to the community when it's not COVID, but we are accessible, and we try to be in the community in very big ways. I don't know if you've ever heard this stat before. I just heard it said by one of our leaders about a year ago, is that Tempe, if it were kind of considered a city, would be the fourth largest city in the state of Arizona. In population, when we were loaded with students and staff and the faculty and everything that makes the ASU campus work, we're larger than the city of Yuma. And so that's kind of, we're a big deal in that way, one of the largest public institutions in the United States of America. We divide our university into schools and centers and all that stuff. And the one we're introducing you today is the School of Earth and Space Exploration. And a short history of our school is that approximately 12 years ago, one of our leaders said that, really what we need to do is create a unique model in schools of geology and astronomy. We're going to do those two things together. We're going to pull our astronomers away from the Department of Physics, and we're going to marry them to our geology team. And together, we're going to have geology and astronomy taught in the same environment. And what that did for us is offered a whole range of degrees about Earth systems and exploration systems that not only operate here on the surface of Earth, but also on planets and other places. We also became kind of a go-to place for meteoritics. You're going to hear from one of our students today about the Center for Meteorite Studies. We then are also go-to people for the exploration of the surfaces and understanding the properties and the processes and the things that make the surface of another planet. And then we can learn from space exploration. We learn from comets and meteorites and the compounds that are in them about the formation of the Earth itself. And so we play that game very, very well. It's not to say we're not into cosmology and deep space. We are, and it's not to say that we've divorced from the pure geological science. We haven't. We're all over the Earth and in many, many ways. And just in space missions, just real quickly, just by some numbers, I just counted up, and we have 11 missions that we are principal investigators on right now. And one of those started 22 years ago. So when we get into space and when we sort of start to do some sort of a process, sometimes these things last for a long time. Respectively, 10, 20 years ago and 18 years ago, we've been flying around Mars with imagers and detectors and spectrometers and sort of mapping the surface of that planet for almost 2 decades. We also have been doing the same thing for almost 12 years. We've been flying around the moon with a suite of cameras, and we're imaging the surface of the moon to a level that has never been done before. We can actually see the size of a footprint on the moon from space. And so that's all part of the process of taking future exploration to the moon. So those are, and then we are also involved in the preparation of 14 more missions. 3 of them are going to deploy in some meaningful way at the end of this year. So right now we are celebrating the big, huge success of the Perseverance rover landing on Mars, and you're going to hear about that from Alicia in a little bit. But that doesn't mean that's the only thing we do. And so to be a communicator and somebody that is part of this communication team in the community outreach group, we have to pick and choose what we're going to talk about today because we're excited about it all. There are amazing researchers and students running around in our system every single day, and they're doing amazing work, and it's very, very difficult to talk about it all at once. In the background, you see there is a theater behind me. It's empty. Unfortunately, that's the way things are right now. So just a little update about the university is any student that has a class can come to ASU and participate in our classes. And any student can also choose to basically take their classes online. And that's just a COVID-related program. So we're making the buildings accessible, and we're also making the classes accessible online, hybrid situation. But we fully expect to be back in August. This is the plan. We think we are going to be back. We're going to be full-time. We're going to have classes filled with students, and we're going to be as close to back to normal as we can on a student standpoint. And then Meg and Kim and I, as team of this the community outreach group, we are planning to actually start launching public programs back into our system in the middle of next semester. That's going to be about October, and then full-time by January. Now, these are plans, and plans can be interrupted by new changes and things like that in the virus, but this is our near future. We're really looking forward to it, and we want everybody that participates in the program today to think about the university as a resource, to think about the School of Earth and Space Exploration as absolutely a visitable place in the future. And we're going to want to see you. We're going to give you a little sample of some of the things we're working on today. So I also wanted to kind of do a little shout out for a geology side as well. There's a thing that happens as a really good example of a resource that a university can be. Who heard about last Friday? There was a giant earthquake about 1,000 kilometers north of New Zealand. It was a subduction earthquake. It is actually, that means it's an earthquake that happened deep under the ocean and deep into the earth under plate subduction, the Pacific plate subducting under the South Pacific plate. And it was 8.1 on the Richter scale. Well, we have researchers on site that knew about it, researched it, sent out the information about it, and have kind of informed the public about what that meant to us and what it meant to the people there and why it happened and what is it like to experience an earthquake there. And so I'm going to play for you a quick little video by Ramon Aerosmith, and he is one of the leaders in earthquake research. And he is the type of person that can react immediately to a new science thing that happens, a phenomenon that we just never, it didn't happen before last Friday, but last Friday we were able to pick it up and get some information out about it. So here's a little sort of bit about what Ramon does and his research. Go ahead.
Everyone, I'm Ramon Aerosmith. I'm a professor in the School of Earth and Space Exploration at Arizona State University, and I wanted to provide just a very quick welcome and overview to my research group. And our laboratory is largely in the field, and also we use a lot of high resolution topography, and so wanted to just use this as an opportunity to show some cool imagery. So this is a strip of meter scale topography along the San Andreas Fault in Central California. See these really kind of cool, strange patterns of the structures. Here's a double stranded piece of the fault zone, and things that are interesting to me is how does this structure evolve? How does it record the history of past earthquakes along this really major fault of California? And here we're flying to the southeast, and we come to the southern Carrizo Plain where the data kind of broaden the topography hillshade, and this really spectacular feature called the Dragon's Back is here. It's about 3 kilometers long, parallel to the fault zone. It's several hundred meters wide, and it's about 150 meters tall, and it records kind of progressive uplift and offset along the fault zone, and has been a natural laboratory for us to look at the interactions between topography or surface processes and tectonic processes. And this also was part of my PhD work, so always kind of close to my heart. Moving on, here's another really interesting project we've worked on. This is a point cloud that was rendered in the browser, and it shows us the topography. This is about a kilometer in scale over a volcano in northern Mexico, just south of the US-Mexico border. It's called the Tecolote volcano, and I've been working with Professor Amanda Clark to understand what's going on here. You see these really interesting fractures that are sort of concentric around these vents in the middle here. So this was produced from a drone, and this and the prior data are available on the Open Topography Project, which is a major data sharing project for topographic data that I help lead. And then here's a final view of another interesting project. Something that makes me quite excited is the example of an earthquake surface rupture that is from 2008 actually, but we were in the field a couple years ago, and you can see some people down there at the bottom. And actually also, if you look very carefully on the right in the middle, there's a white thing is another drone flying. But we're using the topography data from the drones and also our field mapping to understand the fracture pattern that was associated with this earthquake rupture. And you can see people there making measurements in the field to compare with what we observe from the air. But this is probably an unusual earthquake. It probably hasn't happened that many times in this particular fault zone, although there is some evidence of prior events in the landscape. And unfortunately, it was devastating to a local village, and so it reminds us about the importance of studying this phenomena. So anyway, please don't be shy. If you have any questions about these topics or other ones, please communicate with me, and best wishes.
Excellent. So science is happening all the time, and I'm just going to kind of leave the story of the school in just a moment with one more comment, is that ASU has been an important part of the history of Tempe, but that doesn't mean that ASU can be considered something that happened in the past. ASU is something that's happening right now. The researchers, 35 faculty that are involved in the earth sciences, 35 faculty that are involved in space and space research, they're going to work every day studying the phenomenon that impacts us every day. A historical institution that has absolute relevance today and will into the future. Ramon, in the early video, we mentioned the Center for Meteorite Studies, and one place where space and the Earth interact is in meteorites. And I'm going to introduce Zineb to actually tell us a little bit about her work at the Center for Meteorite Studies. Thank you.
Hi everyone, my name is Zainab Muti, and I'm an undergraduate student at ASU. I'm majoring in microbiology, however my research is actually in meteorites. So today I'm going to be talking a little bit about meteorites themselves, as well as my research and the Center for Meteorite Studies and the ASU Space Grant. So, I think so. Thank you. So, yes, the ASU Center for Meteorite Studies was established in 1961, and it was one of the first established research institutes at ASU. It is part of the ASU School of Earth and Space Exploration, and it has one of the largest collections of meteorites in the world, and actually the largest university collection, and it has over 40,000 individual specimens. So currently there's a lot of research on those meteorites, but there's still so much more that needs to be done, and ASU Center is really involved in that. The Center for Meteorite Studies is a part of ASU's School of Earth and Space Exploration, and we have many, I'm sorry, when you're able to go in person, you're also welcome to see the gallery of meteorites in the ISTB4 building, but right now we have virtual tours of the gallery. So if you go to our website, you can take a virtual tour of our meteorite collection. And then ASU CC also has many events for the public, like the School of Earth and Space Exploration Day. We also have the ASU Marston Theater Virtual Night Sky presentations, and I think those are on alternating Wednesdays, and those are really, really fun. So the aim of the Center for Meteorite Studies is to pursue new knowledge about the origin of our planetary system through the study of meteorites, in part so that we may understand the pathway to forming habitable worlds. So the ASU NASA Space Grant Program is a program where undergraduate students work with scientific researchers and engineers on STEM-related research for NASA. So STEM stands for science, technology, engineering, and math. We learn how to conduct research, and we work with our research mentors for about a year. So my research mentors are Dr. Gemma Davidson and Dr. Devin Schrader, and they're amazing. And we also focus on informal education and public outreach to help show others both at ASU and in all of Arizona all the possibilities that there are in science. So at the end, we present what we find at poster sessions and symposiums, but we can also present our research at conferences or publish scientific research papers. So with our experience, we can also learn more and hopefully apply that to graduate school or careers in the future. So what is a meteorite? So a meteorite is a meteoroid that has survived falling through our atmosphere and it lands on Earth. So an asteroid is a rocky object in space that orbits the sun. It's smaller than a planet, but it's larger than a rock. And they formed at the beginning of our solar system about 4.6 billion years ago. Most of the time, meteorites come off of asteroids, but they can come off of pretty much any parent body. Now, a meteoroid is when a piece of an asteroid or a comet, or sometimes even the moon, possibly, it breaks off. And the meteor is when a meteoroid enters our atmosphere. So that's what you see in the sky, like shooting stars. Those are actually meteors. So a comet is similar to an asteroid, but instead of being made of rock, it's mostly made of ice and dust. So, here we go. So what are meteorites made of? There are three major types of meteorites, and the types are defined based on their composition. So the first type are iron meteorites, and these are made almost completely of iron nickel metal. They can also have some other minerals in them as well. And then you have stony meteorites, and these are mostly silicon-based minerals. Approximately 94% of observed falls are stony meteorites. And then we have stony iron meteorites, and these ones are really cool. And these are close to equal amounts of metal and silicate crystals. Now, my favorite type of meteorite, besides the ones I study, CM carbonaceous chondrite, are actually these ones with the pallasites. And it looks so pretty, it looks like stained glass to me, so that's why I really like them. And then, so what can they tell us and why are they important? So they're important for many aspects of scientific research. So the first one is astrobiology. So this type of meteorite that I study, they're called CM carbonaceous chondrites, and they're known to have organic materials like amino acids or sugars that are needed for life. So that's why these are really important, because they can tell us whether the places that they came from, their parent bodies, actually have the necessary requirements for life. So they're also important in discovering more about the origin of the universe. So although people have been researching space for hundreds, if not thousands of years, there's still so much we don't know about how everything formed way back in the beginning. They're also sometimes called time capsules. because they can tell us so much about the history of our solar system. They've just been going around space and they land on Earth. So it tells us a lot about places really far away. Some people hope that in the future we'll be able to go to asteroids and mine them. I'm not quite sure if that's going to be actually done, but some people really hope to do that because they contain a lot of metal and it would be really lucrative. But these meteorites can also tell us about how much metals in these parent bodies that these came from. And then lastly, for space travel. So the meteorites can tell us a lot about the characteristics of their parent body, which is often an asteroid. These asteroids can have water on them. So we're hoping that maybe in the future, these could even be used as kind of like a gas station sort of thing or a pit stop for deep space travel. And then, so my research, it focuses on CM carbonaceous chondrites. So it's a type of stony meteorite, and they've been found, as I said before, to have organic material. So what I do is I take images with an electron probe microanalyzer, and then I use those images and elemental maps to measure and compare chondrules and their rims. So here on this first image, it says FeMgSi. So everything that's red is actually iron, everything that's green is magnesium, and everything that's blue is silicon. So this helps us tell exactly what composition is and you can tell all these little inclusions. So this is a chondrule. So a chondrule is a small inclusion found in stony meteorites, and it's made of silicate minerals like olivine and pyroxene. That's the little green and blue you see there. And these were droplets of material from when our early solar system formed that cooled before becoming a part of the parent body. They also have these rims around them. They're surrounded by these little fine grain rims, and it's kind of like a dust rim around it, but we're not quite sure exactly how they formed. So there's two major hypotheses to how and when they formed in our early solar system, but because they're not around every chondrule and they're not found in all carbonaceous chondrites. So I'm comparing 6 different CM carbonaceous chondrites that all have different characteristics, and we're aiming to hopefully discover more about how they formed and hopefully see if our data suggests one hypothesis over the other. And it's really, really cool to me because these formed over 4.6 billion years ago, and through just analyzing different ones, you can tell what happened 4.6 billion years ago. So I really, really do love my research. So thank you so much for everything.
Thank you so much. I believe we have some videos that we'll go ahead and start with. There we go. All righty, thank you so much. I wasn't sure if there was one last video or not, but we can go ahead and get started. So I'll share my screen now. Awesome. So my name is Alicia Hyatt. I studied astrophysics and biology or biological sciences here at Arizona State University. And I'm here to talk to you today about the Mars Perseverance rover, or the Mars 2020 rover. And so just to backtrack a little bit, I also do research in a lab, in a biology lab. It's called the Troop Lab. The professor's name is Heather Troop. And so we are a desert drylands lab, and so we study the desert and soil and climate change. So as you can see, all of the sciences are connected at CC. They're all very interdisciplinary. So like I said, I'm here to talk to you today about the Mars 2020 rover, or better known as the Perseverance rover. And so, oops, sorry, there we go. In order to do that, I'm going to go ahead and talk to you about the timeline. So this is the Mars 2020 rover review. So it launched July 30th, 2020, and it was cruising in space, obviously in July 30th, but it was really in cruising period from August 14th, 2020 to February 18th, 2021. On February 18th, the Perseverance rover entered the atmosphere and began its descent process and its landing process. And then surface operations were able to be completed once the rover was safely landed on the surface, which happened again on February 18th, 2021. And as for surface operations, we are still collecting information. We're still collecting images from this rover. Every single day we're getting data done. So keep looking on the websites, whether that's ASU's MathCamZ website, or whether that is NASA's website as well, to get these incredible images. Or the latest images. And so I kind of spoiled it a little bit as to why we here at ASU care so much about the Mars 2020 rover. And that's because we had a part on it. We had some instruments on it. This is the Mars 2020 rover, or I'm sorry, this is the Mars 2020 rover, or at least a clipping of it so that you can see the instruments on board. And so what ASU so proudly made are these two cameras right here labeled MathCamZ. So they're right over here. And so the MathCamZ cameras, a better image down here, was developed by Professor Jim Bell, Dr. Jim Bell here at the School of Earth and Space Exploration. So him and his team actually built these cameras. And they also built the cameras that were for the Curiosity rover that launched in 2011, landed in 2012. So we built Dr. Bell and his team built the MathCam rover cameras, and then they also built the MathCamZ cameras for the rover, for the Mars 2020 rover. And so what's really interesting is that these cameras operate just like our eyes do, right? So we have two eyes for something called depth perception. It gives us the ability to determine how close or how far away something is. And so by having these two cameras on Curiosity, or on the Mars 2020 rover on Perseverance, we're giving the rover the ability to have this depth perception, or to send us images with this depth perception, right? And so that's really great for science. Whether that's navigating where the rover goes, or whether that's determining how close or how far away something is in an image or a 3D image that we've gotten here. So we're really excited to be a part of this, this rover and to have instruments on board. And so this is just a little bit closer of a 3D generated model of the Perseverance rover. So these two boxes right here are the mast cams. So the camera's attached to the mast, right? Very clever in the naming. And I forgot to mention that the Z in MathCamZ now stands for zoom. So we have this zooming availability that we didn't have with the Curiosity rover. And so if you look here on the very right is the very first image we have back from the Perseverance rover after it landed. And on the left, we have the very first colored image, fully colored image from the from the Perseverance rover, not Curiosity, the Perseverance rover. And so this was taken just a couple of weeks ago, and it's very exciting. But this image right here is the first 360-degree panoramic photo taken by the Mastcam Z cameras that Dr. Jim Bell and his team here at ASU built. And so we're really excited to share this photo with you. And so if you're looking here, so this is how the rover actually took 142 individual photos to create this 360-degree panoramic visual that we saw earlier. And so this is it, every single photo kind of coming together to make the entire panoramic that we just saw. So like I said, 142 images to make this 360-degree panoramic. Alrighty, I guess I'll let it complete. There we go. Very fascinating stuff. And like I said, we're still getting images constantly. So make sure you check ASU's website or the Mastcam Z website, as well as NASA and JPL's website for the latest images on this. All right, there we go. And so here we are on landing day. So a couple of docents got together and were able to help the team. The team is in the Hawaiian shirts. You can see they have little Mastcam cameras all over them. They're really, really cute and interesting. And then we also had, of course, Krispy Kreme Mars donuts to celebrate the occasion. So everybody's masked up and, you know, safety precautions were taken, but we're all watching through the glass window in mission ops as Perseverance touched down on Mars. And so it was a very emotional day, a very emotional time. You could see from that reactions video earlier that it was a really important day, and not only for science, but just for humans in general. So oops, I'm so sorry. Let me stop sharing. I clicked the wrong thing. Oops. Let me go back to full screen. So sorry. There you go. So with that being said, I'll reshare. All right. So with that being said, ASU is a part of many missions, many NASA missions and many other missions as well. How many times can I say that word, right? And so we were a part of the Curiosity rover. We're a part of the Mars 2020 or the Perseverance rover. And as we mentioned earlier, the OSIRIS-REx mission, and so many more. So we highly encourage you to stop by our facilities when we're open again and to take a look at some of the missions that we have going on, but also do your own exploring. Go ahead and check out our websites and stay up to date on all the current missions and information that we have. So with that being said, thank you so much. And I'd like to pass things back to Rick.
Hey, thank you. And thank you very much, Alicia. And thank you, Zainab. I think that was great presentations and I really appreciate it. So we have two more quick videos. I just, again, we love the reaction shots. So we're going to play one that was made by JPL, and it has some of the landing information and some of the video, but it's interspersed with some very, very excited researchers that were part of this project. And then the second one is very short. We played it for you just a minute ago, but it didn't have sound. So I'm going to so first one, you're going to be looking at JPL reaction to the landing. And the second one, you're going to look at ASU reaction to the landing. Go ahead, Meg, when you're ready.
Propulsion, go. EDL phase lead, go.
We have deemed Perseverance ready to execute entry, descent, and landing on her own. Confirmation of entry interface. Perseverance is currently going 5.3 kilometers per second, about 120 kilometers from the surface of Mars. It will start controlling its path to the landing target. Parachute has deployed and we are seeing significant deceleration. The heat shield has been separated. Perseverance now has radar lock on the ground. The back shell has separated. Skyframe maneuver has started, about 20 meters off the surface.
Tango Delta, nominal.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.
And then right into the next one, real short. Thanks.
Whoa! This is a good man.
I guess you can't see that too many times. So the gentleman you saw just making a fool of himself was Jim Bell, and he is the PI. He's the guy that designed the camera system, the zoom cam that Alicia was talking about. But I think as important, what you saw there is a glass partition. So inside that little room, which is protected, and it's a NASA certified room, there was a whole bunch of students. And to me, that's the most important part of what's going on here. It's the mission is making history, right? So we're on Mars with another instrument. It's going to be really amazing. But the fact is that there's a huge, gigantic team that participates in the development of these projects, the deployment of these projects, and in this particular case, students are actually there on site in that little room, and you can come when the campus opens again. You can kind of come, you'll see them working. They're receiving the information from Mars. So can you imagine, right, being an 18, 19, 20, 21-year-old, and you're going to work every day, and you're receiving actually images and data and stuff from another planet every single day. They're processing it, they're labeling it, they're categorizing it, they're color correcting for it. They have their processes to do, but they're playing a vital role in the delivery of that science. So remember my stool, right? Teaching, yes, this is all about students. We are a place where students can engage with professors on all levels and learn at the university and get their degrees. We are a research institution, so we have people like Jim Bell on board that are helping to sort of make the world excited about science through their research. And then you have the communications. It's imbued in everything we do, and so we need to make sure that you know that ASU is ready to communicate. If you have questions about our missions, if you want to sort of learn something, if you want to know a little bit deeper about what's going on, there are many ways to engage with our university. I'm going to just describe to you a couple. First one is hit a website. CC has a website, and you can go. There's a tab on our cover page. It says public engagement. We mean it, right? That is where you come in. So you can just go to the cover page, public engagement, and you'll find in there a whole raft of things that you can. Right now, everything we do is virtual. Later, those will become programs, and those will become visitable, and they'll become calendared. And it just keep in mind every once in a while, just check us out. It's always new. There's always something new going on, and it's always exciting. And so you can kind of use that to see that. Now I'm going to invite you to one tonight. So every other Wednesday night, we have a program called the Virtual Night Sky, and it's hosted by myself. Tonight we'll have a guest. Sometimes we bring in researchers and faculty. There's a guest faculty tonight. We cover a slightly different subject all the time. They're about an hour long. So every other Wednesday from 7 to 8 o'clock. And they're free and they're accessible. And so you can do exactly what I said. Website, School of Earth and Space Exploration, public engagement, navigate to the virtual night sky. And there's a way to register and sort of like and become a part of that and do it every week. In that particular case, what we're trying to do is give you a chance to sort of witness something, see something going on in the sky. We're talking about stars and star phenomenon and moons and suns and eclipses and meteor showers and all the kind of things that we can see. But we're also adding that layer of science behind them. So tonight we're actually talking about a field of stars that's visible in the night sky this time of year. And then we're relating the different varying colors of those stars to the research and the science that goes into what makes that special. And that's where Dr. Patrick Young will join us. And he's an astrophysicist, and he'll tell us the importance of the color of stars, the different way to engage. And you can do that starting tonight and then every other Wednesday going forward. So we really appreciate being a part of your lunchtime program. Vic, this is amazing. You've really put together a really nice setup. And I believe we'd love to come back and give you updates on projects, and we'd like to be back more often than just every once in a while. So thank you very much for having us on, and I'll turn it back over to you, Vic, and let you have the closing comments. Thanks. You're going to have to unmute.
You know, you'd think as long as I've been doing this, I would remember to unmute. Thank you so much. As I said at the beginning, this is kind of a personal presentation because astronomy and what we're accomplishing is a big love of mine. In watching some of the videos and these presentations, I'm struck by several things. If I'm old enough, and many of our people in the audience today are old enough to go back to the beginning of the space program. And I wanted nothing more when I was a youngster to be an astronaut. But if you look at images from the early space program, it was a room full of middle-aged and older white men. And the diversity that's in the program today is really astounding. This is a field that not that long ago was really closed to women. It was a very difficult exercise to get into these kind of sciences, and let alone get hired by NASA or JPL. There have been a couple of documentaries about pioneering women that have done this, and they paved the way for those that are there today. And something else that is not always thought about it is by those that are participating in this program. My understanding is that it may go back 20 years, the Perseverance mission, and the program, that's the career for many people. And I can only imagine what the tension is like after you've spent years and years developing the instruments and the science that allows something like Perseverance to get to Mars and then to be able to land safely. The tension must be enormous, plus the fact that you can't do anything about it. The time delay does not permit any last minute adjustments. When Perseverance entered the atmosphere, it was on its own. And to see that craft come down in the complex way that it did, I could watch that video constantly. It really is a remarkable accomplishment. And to know that much of it is right here in our backyard with ASU. That program is really astounding, and I would invite everyone to participate in the labs or the nighttime virtual experiences that the ASU is offering right now. I've watched a couple of them, and they're really informative. They're not highly technical. They're meant for an audience that just wants to learn more about space in our program. I know there are probably a couple of questions. I've got a few that we talked about in the very beginning, there are obviously critics of space program and how many billions of dollars that go into sending a mission like this to Mars, and we're close to going back to the moon. I think it would help for people to better understand, and Rick, maybe you can answer that. What do we learn from these missions to Mars and the exploration of other planets? How does that affect us here at home on Earth?
Yeah, let me let me kind of couch it about three different ways. First, we believe, and I think most people sort of feel inherently, that exploration is a human imperative. There has never, ever been a time in the history of humans on Earth for millions of years that they haven't explored. You had to explore to survive. You had to know what's over that next mountain, and if there's more antelope over there than there are over here, you need to know that, because that's your survival. So exploration is kind of in us, and so we're going to do it, and it's going to happen. And then I think you alluded to it earlier. Yes, the technology that comes out of something. I mean, so Jim Bell is building zoom cameras, and they're going to go to Mars and all that stuff. But that whole process of how to make things that reliable, how to make things that will operate under the vibrations and coldness and all that stuff just makes our technologies better here on Earth. And everything we use, from medical technologies to just your run-of-the-mill TV and channel changers, comes from some sort of process that somebody had to do all of that thinking and research and background and testing and all this stuff to make those things. The spin-offs then are of benefit to everybody. And then I'm going to bring it a little closer to home. We actually also started a program on site about 3 or 4 years ago, and it's called New Space. And it was basically formed by Dr. Crow. He said, hey, we should do this. And Jim Bell was one of the leaders in that. And what they do is they examine very closely the spin-off economic benefit that a space program like at ASU does for Arizona. And one of their first charges was to just figure out how many companies in Arizona have something to do with space programs. And it turned out to be in the 500s, like 550 just jumped off the wall. And these are subcontractors and subcontractors, but these are people that build things. These are people that work on products. They build on little gadgets and all that stuff for you, but they also do this for the space program. And so this funding, the way this money works, right, it comes out of government, it comes out of NASA or National Science Foundation. It flows through something like a university, but then the spin-off back out into the business community and all that is just enormous. And Arizona has always been something of an astronomy state, and we're research favorable. We're known as a go-to place for this, not only ASU, but U of A and NAU. And so that actually is important on all levels. The benefit from how this comes together and how this research happens absolutely benefits everybody in the Valley and everybody in Arizona in some way or another. So I hope that kind of starts to answer that. I mean, it's almost too big to say there's this direct thing that happens here and it goes and happens here. There's all kinds of different feelers in the development of products and the development of technology that it has fingers all over the place. So hope that helps.
Yeah, absolutely. And one of the more common things I think people are aware of, the computing capacity of your smartphone, your cell phone, is infinitely greater than that system that went to the moon on the Apollo missions. And I really wonder, would we have cell phones today? This miniaturization of technology, if we didn't have space programs. And also, I think it's important, and anyone can jump in on that, what we can learn about how Mars developed, the theory being that there was likely water and an atmosphere on Mars. What happened? And is there a lesson there that we can learn that might be the future of Earth?
You're absolutely right. In fact, Perseverance rover has been getting all of the publicity, and that's where we concentrated today. But almost at exactly the same time, another spacecraft arrived at Mars, and it was actually, this is a spacecraft that actually is operated by the United Arab Emirates. But we are a participant in this one too, because we do spectroscopy, and that is basically the measurement of light that is essentially outside of the visual spectrum. And they just turned in new science yesterday. I just was reading about it this morning before we got this. And what they're doing is looking at the atmospherics of Mars. So it's an orbiter, not a lander, and they're flying around. And they actually are, they can tell real time what the surface temperature is and what the temperature of the atmosphere all the way up through. And so they're looking at that relationship between those two things. We know that the atmosphere of Mars used to be thicker, wetter, hotter, warmer, all this stuff many, many years ago, more matching an Earth type of atmosphere. But we also know today, much of that atmosphere just escapes into space. Mars doesn't have the ability to hang on to it like the Earth does. And so those changes and what's going on, as you just said, what was Mars like a billion years ago and 2 billion years ago, and what's Mars like today, and what happened in between, and what are all those mechanics that make that happen? It's absolutely vital for us to know about sort of our own atmosphere and what we're doing to it, and how to make changes to protect it as well. So life doesn't happen unless there's this really big, beautiful, thin volume of air around us, and it's very important to know everything we can about it. If we have to go to Mars to find out something, all the better. Let's go do that. So.
Yes, absolutely. And to just go back what you were talking about economics, Zainab was doing research while you were commenting, and she notes that the government has spent approximately $4.5 trillion in fiscal year 2019, of which 0.5%, 22.6 billion was provided to NASA. So to some people that may seem like a lot of money, but in the overall scheme, NASA is doing an excellent job of using the limited resources that it's getting. Plus, partnering
less than we used to. Yeah, that's less than we used to tip at the local restaurant when we used to go to restaurants.
Oh, yeah, that's a thought too. And maybe Alicia, you can jump in on this. One thing that I didn't hear you mention that everybody is excited about is this drone, which will be making the first flight of an aerial vehicle on another planet. How is that going to work?
Yes, so I am by no means an expert, so I can give you what I know. But Ingenuity, I believe, is the name of this little helicopter drone that we have. And it will, in fact, launch in the next couple weeks, I believe, and start taking these aerial photos that we've never had before. And so, yes, we've had satellites over Mars that have been able to take photos. And yes, we've had rovers on Mars and landers that have been able to take these incredible photos and images, but we have not had something quite up to this caliber. So we're very excited to see all of the new photos and information that we get in this aerial kind of drone view. So
when is that first flight expected to take place?
I believe in a couple weeks. I could be wrong. Maybe that's something I can look up.
I'm not sure. I'm not sure they actually have a very specific targeted date. And I, like Alicia, I know when all the landing activity and all the excitement about that goes. They said within 2 months. So now it's been on the surface for about 3 weeks, and so I'm guessing within the next 2 to 5 weeks we'll do that. And it actually it drops out of the bottom of the spacecraft, and it's not mobile itself. So I mean, out of the rover. So it's going to hit the surface, and then the rover drives away from it to expose it. It has solar panels, so it has to charge itself up, and then it'll start to fly. But I think the importance of having that little drone and that ability to see kind of in a bigger aerial view, the rover itself has its cameras on board, and we use that for navigation. So you can imagine, okay, so we're looking out there and we're searching what we can search, and we're sort of like telling this rover to drive sometimes 3 or 4 feet per night, right? I mean, it's not moving very fast. So to get that, but for the life of the mission, to make really good decisions about which direction you're going to go and what science you're going to pick up along the way, to have this little bit longer view, to have basically be able to kind of see some of the interesting scientific objects some 100 yards away from the rover instead of just 30 or 40 feet ahead of it, I think is going to make a big difference, especially in the terrain it landed on. It's very varied. There's lots of elevation changes. There's lots of things to go explore. And so I think that's going to help quite a little bit. But interestingly, they didn't write any necessarily science into the mission of the drone. The mission of the drone is just to see if you can fly a drone on Mars and see if that thing will get off the ground and see if it'll take pictures. And so if they can use it also as a navigating tool or as part of the science mission, then all the better. But it's it will have a successful mission if it flies and takes a picture. And so that'll be kind of fun. And of course, that's the type of thing we'll use in future missions as well.
Well, and all of our drones here are geared to the density of our atmosphere, and the atmosphere of Mars is much less dense, and its composition is different. So just engineering the technology to see if it'll get off the ground and fly is exciting in itself.
It's only 4 pounds, go ahead. It's only 4 pounds, as I understand, and it only really has this one function. It's just going to take pictures straight down, and so it's a very real simple device, but with complicated engineering because of just what you talked about. The atmosphere is so much thinner than here. It's going to be amazing to see it operate.
And you've alluded to it. Meg just said that Ingenuity is called a proof of concept experiment, and if it is successful, larger ones might come that can do other things. But it's a lot different looking from 100 miles or 200 miles or 1,000 in space as opposed to 100 feet off the ground. That's going to give a whole different perspective. This one might be for Zena, since she's interested in meteorites and things flying around in space. Everybody worries about whether that craft is going to get to its destination and land successfully. But along the way, there's a lot of stuff out there, little asteroids and space debris. What are the chances of this very expensive, complex piece of equipment getting struck by something out there?
So, I'm not an expert on the mission, but I do know that most asteroids are located in the asteroid belt, and they have so much technology that goes into plotting its course. So I'm pretty sure that they monitor it, and they have set paths that they know are probably the safest paths to take. But most of the time, we can track things in the sky pretty easily, and we know generally where most of these asteroids are located.
In my understanding is even for the space station, just a piece of space dust, a micro particle, can cause a lot of damage. And I'm not sure how you can avoid that, although it apparently has not affected the space station, or they've got ways of protecting it.
Yes, there are so many. I'm sorry, go ahead.
No, go ahead.
They have so many different ways that they, I know, not only protect equipment, but there's so many different ways that they track where things are, and they monitor where things are going, so they can kind of predict where they will be, and they can figure out the safest way. So. And
you mentioned, meteorites hit all areas of the Earth. I think some places are richer in meteorite strikes than others, but is Arizona a good place for meteorites? We do have a few pretty good examples, and if it is, how does one know that they've discovered a meteorite laying on the ground?
So meteorites fall everywhere, but they're mostly found and recovered more easily in deserts because these are geologically stable places. So Arizona being a desert, also Antarctica is a desert, even though it's not hot, it just doesn't have very much rain or anything. And then the Mojave Desert and all these other deserts, you can find them a lot easier. However, telling them apart from different rocks might be a little bit difficult. There tend to be darker or black, like just black or darker, but there are some that are lighter colors as well. So if you're somewhere like the Sahara Desert and you see just a black rock and and all the sand, it would most likely probably be a meteorite. But here in Arizona, it might be a little bit more difficult to tell just because we have rocks that are different colors and stuff like that.
Have you done meteorite exploration? Have you made any discoveries out in the field?
I have not this past year with COVID and everything, but in the future, I hope to go to Antarctica. That's like a dream of mine. They send these they send these teams of people up and they do meteorite recovery, and they go on these little like, I don't know what they're called for ice, like a jet ski for ice. I live in Arizona. I don't know what they're called. And and they go and they have a section that they want to look at, and they go as a team and they look for them. So that's always something I've really wanted to do. But pretty much any geologically stable place, you can find them a lot easier than anywhere else.
Well, I think that's cheating. I mean, a meteorite's going to stand out in the snow in Antarctica as opposed to the desert. A couple of years ago, we were in the Atacama Desert, the very high desert in Chile, where they do have the ALMA Observatory, and that's a fertile ground for meteorites. In fact, they have a pretty good museum there. Any advice for people that think they might have discovered one? I assume you'd like to see that shared with the science community because there are things you can learn from them.
I know before that the Center for Meteorite Studies used to have something where you can take in what you think is a meteorite and they could look at it and tell you. They've stopped doing that at the moment, but I think if you go to the website for the Center for Meteorite Studies, they have a link that tells you where to take it. So they can I think it's a state group, but they have a link on our website which tells you where to take it. So they can tell you if it's a meteorite or not.
Ah, very good.
Let me add that website also kind of gives you at least the 4 or 5 just first questions to ask. Is it this? Is it this? Is it this? And if you can kind of like get through that, then you might have something. So you can learn just by even going to the website and seeing what that is. And then we also, when we get back to public programming, traditionally there are 2 times a year that you can actually bring a meteorite into. We have these big open houses, and you can bring your sample, your suspected sample, into our place, and there are people that work for the Center for Meteorite Studies that will just tell you exactly what they think it is or isn't, or sometimes we call them meteor wrongs if you're not exactly a right, but it's good to learn anyway. So.
Also, for anyone that wants to do a little bit of research, meteorites.asu.edu is ASU's site for that. With regard to the Mastcam Z, since it was developed and built, did ASU actually build the camera first?
We did for both for Curiosity rover and for the Mars Perseverance rover. Yeah.
And since it's your baby, who operates it? Is it operated at ASU or through JPL or some other agency?
It is operated here at Arizona State University in partnership with a university, I believe in San Diego, but I could be wrong on that. But there is a joint partnership with someone in California. It's not JPL, so from what I remember, but yes, ASU is involved.
But at ASU, you've got a joystick or whatever you want, whatever the device is to move it around.
Actually, not exactly. Yeah, go ahead.
Sorry,
it's actually not exact.
Sorry, ASU with the Malin Science Space Systems in California. So.
Okay.
But actually, the driving of the rover is a very, very complicated thing. And so effectively, there's a team of researchers that have interest in all of the different instruments. We're interested in those Mastcam Z cameras, but they meet basically every day to talk about what the mission is going to do. What did we do yesterday? What did we get as science? What do we want to do tomorrow? And then it's not a joystick, it's not driven that way, but code is transmitted up to the rover. And that code could be very, very simple instructions. And so it could be just move forward 3 meters and, turn your wheels to the right. And that's then what it does. Within all of the instrumentation and everything, then the same thing happens. And so we're going to want 4 different images taken as it goes. Once it stops, we're going to want the mast to turn right and take another image. They figure all that stuff out. They basically write those instructions, send them to the rover. Then the rover does it on its own. It just does what it was instructed to do, sends back the information, and then it's reviewed. And here we go all over again. And that's actually done on a daily basis to make the rover work. So never asking it to do very much. It does not move very far any given day. And so,
Yeah,
Well,
absolutely.
and I think that's, go ahead.
Oh, I was just going to say the mission ops team, the women you saw celebrating in the glass room in that video, they change their schedule every single day to accommodate Mars time. So they come in 40 minutes later every day to just get that data dump on time, or at least they were for a while. I'm not sure if they still are, but yeah, I thought
think
that
they
was
still
very,
are.
I think so
They're
too. I
starting to
haven't
come
seen
in
them.
before I go home at night. So I can see them
Exactly.
changing.
Now, the Mars day is a little bit different. What do they call it? Soul?
They call it a
measure
soul.
Cool.
It's 50 minutes longer than an Earth day. So, and that's it doesn't have to be. I mean, planets spin at different rates, and it's just kind of a quirk that our days are close but not exactly the same.
So look to the future. What we're very likely going to have some manned missions to the moon soon, which will help prepare for longer space flight. When do you think, or if, we will send humans to Mars? And Alicia, you look young enough. Rick, you're kind of in the middle ground. Would you want to go and be one of those first to go to Mars?
Absolutely. Sign me up. I would do it. I definitely think that we're going to have crewed missions within our lifetime to Mars. I don't know that we'll be colonizing it anytime soon, but I definitely think getting someone there, or at least back to the moon, I foresee that happening pretty soon, in the next couple of decades, in my opinion. And yes,
how much
to go?
How much more can we learn? Our technology is so great with this robotic equipment. How much more do you think we can learn by actually sending a human to Mars?
I don't know if we could measure how much more science we could do, honestly, with just instruments that are there, or just the ability to make real-time decision and choices when it comes to specimens or whatever the case may be. So I personally think having a person there is invaluable in a science aspect, but also just kind of in a human space exploration kind of sense. I think it's crucial that we send people out and beyond, because I think, as Rick mentioned, exploring is in our human nature, and it's so important. And I think with exploring space, with exploring the universe, you can't do that without leaving where you are and going out. So I think it's a good morale booster, if you will. So,
and it's early in the game, but there is discussion, I think it's gone beyond science fiction, about creating some sort of an atmosphere, in Mars that
you need to take that.
Would make the planet habitable. Sorry about the phone.
Terraforming has definitely been a discussion. It is a discussion. I mean, I've taken a course specifically dedicated to terraforming the moon or Mars. So it's definitely something that's semi-realistic, I would say, within like our science capabilities. Now, as for whether or not we should do that, I think that's an entirely different argument that you're going to need to save for, you know, philosophers and astronomers and, you know, kind of everyone, because we start worrying about although we don't see aliens on the planet, right? We don't see little green guys. We haven't sent a human there. We have not explored every inch of this planet. So we don't know if there's microbes that are, you know, somewhere beneath the surface. We don't know if there's bacteria somewhere, or whatever the case may be. So to say we want to terraform this planet is, in my opinion, a little premature for all of the science that we need to get done first before we could even open that discussion, let alone like the morals that come with it and so on and so forth. So yeah, it's a very complicated manner, and I guess it really depends on who you ask their opinion on.
And I really, I'm amazed at how far we've come. Curiosity and those early rovers have done a marvelous job. One is still running years after we thought it wouldn't last. And now you jump to Perseverance. What's the next generation going to be like? How much more is it going to be able to do and explore? It's really exciting. I want to thank you. I hope we will have you back because
Yeah, absolutely.
Whatever your generation is, this is exciting stuff, and I am thrilled to see younger people getting really interested in this. And as I say, my generation, it was pretty straightforward, and particularly a woman had a lot of difficulty getting into this. And some of the smartest minds are women, and they should have been contributing a lot longer. So I'm thrilled to have you here, Alicia, and Zainab and Rick. This has really been informative. Let me just remind everybody too that they were talking about the Marston Virtual Night Sky program that is tonight, and the website is sese.asu.edu, and that should get you there. And I've watched Rick host a couple of them, and he does a great job. And just looking up at the sky, it's not easy here in the valley. We don't see very much, but understanding the magnitude of our universe, it should make us a little bit more humble about the place on which we live, and maybe get us working together more collaboratively to save our planet. So let me just remind everyone that next month, Don Ryden, who is a well-known preservation architect, will be wrapping up this season of Lunch Talks. That's on April 14th. And he's going to be talking about one of the most significant pair of architects that the city has ever had. The Goodwin family was a large family that came to Tempe in the 19th century. Garfield Goodwin was a mayor. He built Goodwin's Indian store. A lot of people remember that on Mill Avenue. May Hurd bought some of the first pieces for her collection that eventually became the Hurd Museum from Garfield Goodwin. But his son, Kemper, became one of the premier architects, and all you got to do is walk around the campus of ASU. I think there's something like 4 or 5 buildings that Garfield Goodwin designed. And then when his son Michael grew up, they became partners together, and it was Michael and Garfield that created the upside down pyramid, Tempe's landmark building, the city hall that opened in its centennial year in 1971. So we're looking forward to Don Ryden illuminating us on just who were Michael and Kemper Goodwin. So with that, I want to again thank all the folks at ASU. I want to thank Meg Hufford and Kimberly Batista, Dan Miller, of course, who represents the museum. This was a complex program to pull together. I think it went off rather well, and hope that you have a great month. We will see you in April. Bye-bye.
Thank you.
I think we are.
Sorry, I didn't know you were hosting.
Yeah.